This is a video lesson for Module 5, Lesson 26 and 27. The learning target for these lessons is I can compare fractions greater than 1 by reasoning using benchmark fractions and making like numerators and denominators. So we're going to be looking at two strategies for comparing large improper fractions and mixed numbers. So that's reasoning using benchmark fractions, that's one of the strategies, and then also making like numerators and denominators. So we used these two strategies already when we were comparing fractions that were smaller than 1 and also a little bit more than 1, so we can use these same strategies for these larger fractions as well. So let's go ahead and take a look at our first strategy here. So we're going to be comparing these three fractions by using benchmark fractions. So what I've done here is I have set up a number line, and I have some benchmarks: 3 holes, 4 holes, and 5 holes. And so what I need to do is I need to think about the approximate placement for these three fractions on the number line, and I'm actually going to plot them on the number line. So starting with 13/4, I know that 12/4 is equal to 3 holes, so 13/4 is going to be about 1/4 past 3 holes. So that's going to fall about right here on the number line. And then moving over to 9/2, I know that 8/2 is the same as 4 holes. So 9/2 is going to be 1/2 more than 4 holes. So 9/2 is going to fall about right here on the number line. And then 3 6/8. 6/8 is pretty close. It's only 2/8 away from 4. And so 3 6/8 is going to fall about right here on the number line. And so by using these whole number benchmarks, I was able to find the approximate location of each of these fractions on the number line. So now I can compare them pretty easily. So I know that 13/4 is less than 3 6/8, which is less than 9/2. So 9/2 is the largest, 3 6/8 is the second largest, and 13/4 is the smallest. And I did that by comparing them and finding the relative location for each of the fractions on the number line. So we can continue to use this idea of benchmark fractions when we're just given two improper fractions and asked to compare them. So I'm going to show you what that looks like with 29/7 and 31/8. So first thing I'm going to do is I'm actually going to convert both of these into mixed numbers. So 29/7, if I use decomposition, I know that 28/7 and is 4 holes, and then that leaves me 1/7 left. So this is actually 4 1/7. And if I use decomposition for the second fraction here, I know that 24/8 is equal to 3 holes, and that leaves me 7/8 left. So I get 3 holes and 7/8, or 3 7/8. So now I can determine which one's bigger because I know that 3 7/8 is less than 4 holes, and 4 1/7 is greater than 4 holes. So therefore, 4 1/7 is greater than 3 7/8, which means that 29/7 is greater than 31/8. So you can see how reasoning about the benchmark of 4 holes helped us determine that 4 1/7 is greater than 3 7/8. So that does it for reasoning with benchmark fractions. And the second strategy that we can use to compare fractions is comparing by making like numerators and denominators. So in this problem here, we're comparing 4 1/3 to 4 2/9. So in this case, we can actually decompose this number, and we can put the 4 off to the side. And I'm going to rewrite 1/3 in terms of ninths. So I'm going to multiply the numerator and the denominator by 3 because I want both my denominators to match. So I know that 1/3 is equal to 3/9 because I can multiply the numerator and the denominator by 3. And so I can bring these two back together, and I have 4 3/9. And then since this fraction is already written in ninths, I can just bring that one down to compare. And since we have the same whole number, 4, and we have one more ninth over here than we have over here, 3/9 versus 2/9, I know that 4 and 3/9 is greater than 4 and 2/9, and therefore 4 and 1/3 is greater than 4 and 2/3. So we were able to compare these two fractions by rewriting this fraction so that the denominator matched the fraction and the second fraction in the problem. So by matching the denominators, it was easier to compare the two fractions. So let's see how we can go about solving this next problem here. Let's see if we can either make common numerators or denominators. So right off the bat, we have a mixed number and an improper fraction. So my first step is I'm going to rewrite this improper fraction as a mixed number. So I know that 20/5 is equal to 4 wholes, and that leaves me 3/5 left. So this is the same as 4 and 3/5. So if I bring down this fraction, I have 4 and 3/4. And if you'll notice, the numerators, in this case, are the same. We have 3/4 and 3/5. So since our whole numbers are the same, 4 and 4, we can look at our fractions now. And since the numerators of our fractions are the same, we need to look to our denominators to see which unit is bigger. So in this case, I look at the denominator here, and I'm working with fourths. I have 3 of them. And then here, I'm working with fifths. I have 3/5. And so I think in my head, well, fourths are bigger than fifths, so 4 and 3/4 must be greater than 4 and 3/5. So if that's true, then 4 and 3/4 is greater than 23/5. So the steps I went through, I converted this improper fraction into a mixed number. And then since the numerators matched, I made like numerators. And I was able to compare the size of the unit then, fourths being larger than fifths. And that gave me the answer that 4 and 3/4 is greater than 4 and 3/5, and that 4 and 3/4 is greater than 23/5. So there you have it, our different strategies for comparing mixed numbers and improper fractions. So you should be set to answer any of the questions in the lesson 26 and 27 problem set. But as always, if you get stuck, you can come back and re-watch any of the parts of the video to help you out. So good luck with your problem sets, and thanks for watching.